Hello and welcome to this video tutorial for performing a fluid flow simulation in Ansys Discovery. Let's get started. If this is your first time using Discovery, I suggest you go through the useful information on the welcome screen. This information will help you get up and running with Discovery in a very short time. I also want to point out that we have several interactive tours that I suggest you explore before performing this particular tutorial. Okay, let's get to the home page by clicking here. In the homepage, you have access to recent files and sample files. But let's go to Browse and Open Geometry File. Navigate to the appropriate folder. Select the CAD file that's been provided to you and click Open. This will import this geometry file into Ansys Discovery. Okay, this is the geometry we're going to use. You'll notice it's a manifold of some sort. We have 4 inlets on the left and 1 outlet on the right. You'll also notice in the geometry tree on the left, we have two bodies. We have a solid body in green and a fluid body in a bluish color. Now, in this case, the fluid body has been created for you, but I want to point out that you can also extract the fluid body or create the fluid body yourself in Ansys Discovery, but we're not going to go over that in this tutorial. Please take a look at some of our other tutorials to learn how to do this. Okay, the next thing I want to point out is that by default, Ansys Discovery opens in Explore mode. You can see that at the bottom. Now in Explore mode, we're going to use our GPU-powered solver to perform a real-time simulation to get rapid results for design exploration purposes. In part 2, we're going to use our CPU-based Ansys Fluent solver to do the same simulation. Okay. So now let's get going with applying some boundary conditions. So let's click on this face, which is inlet number 1, and click here to expose the halo. The halo is where you have access to the most commonly used tools. So you see the physics tools over here. You can click here to access geometry editing tools, click here for selection tools, and so on. Okay. In this particular case, we want to apply fluid flow conditions. So let's go here and then click here to launch the Fluid Flow Conditions tool. Now, when you do this, you see the heads-up display or HUD is launched. The HUD is the way in which you're going to interact with all the tools in Ansys Discovery. Now, at any time, you can click F1 to launch the Overlay Help system, which is a very nice way to figure out what's going on with the different tools you come across. To dismiss the overlay help, simply hit F1 again. Okay, so in this case, you'll notice the default fluid flow inlet type is velocity, but we want to use mass flow rate. So click here to change it to mass flow rate. Then click in here and enter a value of 0.01 kg per second. Now you can hit enter or you can hit the check mark. Now you'll notice on the left side in the physics tree, the flow inlet you just created shows up along with some other default conditions that we will talk about later. Now let's apply the other inlet boundary conditions. So just click the second inlet face. You'll notice the head-up display or HUD stays open. We're going to apply the same conditions. So all you have to do is click the green check mark. And let's do the same thing 2 more times. So you see we have our 4 inlets defined. They show up on the left side in the physics tree. Now let's click here and then use this drop-down menu to switch to fluid flow outlet. Accept all the defaults and click the check mark. So we just defined the outlet, okay, as a pressure outlet. Now we're done applying our inlets and outlets. So to dismiss the heads-up display, simply hit escape a couple of times. Okay, now I want to point out that by default, the material property that's used for a fluid flow simulation is liquid water. Now we want to use air, so how do we change that? So one way to do that is to simply double click on the physics tree to expose the heads-up display for material properties and use this drop-down menu to expose the default materials available to you. This is a small list by default, but I want to point out that if you have access to the Ansys Granta MDS license, you'll have access to more than 700 additional materials. But for this tutorial, just choose the default air. Okay, So you'll notice this has changed from water to air in the tree. Now hit escape a couple of times to dismiss the heads up display. Now, I also want to point out down at the bottom, you'll notice the simulation information display, or SID. The SID is just a handy place where relevant information on your simulation is displayed. So in this case, we can see an icon in the middle, which indicates that we're solving a fluid flow simulation. And if you do the other tutorials, you'll notice that that icon changes depending on the type of physics that you're interested in. I also want to point out that if you hover your mouse over here, we have access to a fidelity slider. Okay, so you can click on different points in this fidelity slider to use more memory from your GPU and thereby allow you to resolve the geometry with more detail. Okay, we're going to accept the defaults, but I just want to point out this is how you increase the fidelity of your simulation. I also want to point out that you can click Size Preview to be able to see what that fidelity looks like in a physical sense. So the default fidelity for my GPU results in a discretization of about 0.8 millimeters of the geometry. Okay, so just another feature we have to help you understand what's going on with the simulation. Okay. So that's pretty much it. All you have to do to start the simulation is click the green Solve button. Now you will notice that in a couple of seconds, you'll see your simulation results. Okay. There we have it. So we see some streamlines. Now let's take a closer look at what's going on. So let's make the solid body transparent. To do that, click on any face in the solid body and then click here and then here to turn that transparent. Okay, so you see by default we have streamlines. You'll also notice the SID has a green line around it and a white progress indicator that is spinning around. That indicates that the solution is still running, it's still converging, but you can start observing results right away. So streamlines are the default results. You can click here and move this streamline emitter to different locations, as you see me doing over here. Okay. All your result controls are on the bottom right corner. So let's turn on some different result types. So let's turn off streamlines by clicking here and then click here to turn on contours. So by default, we're looking at contours of velocity. Okay, this is kind of a 3D rendering. You can change the variable being displayed by clicking here and let's say static pressure. And you'll notice that each of these post-processing options has submenus. So for example, I can change the rendering type. So play around with this to get a feel for it. Okay, let's change this back to velocity. Now let's take a look at some other post-processing types. So let's turn off contours and let's turn on 3D velocity vectors. You can see what that looks like. You'll notice, by the way, as we're looking at results, the white progress indicator has stopped spinning around, which means that the solution is done, which is good. I just want to show you one more thing. Let's turn off velocity vectors and turn on particle track. And once again, there's submenus that I encourage you to play with as you go along. Okay, up in the top right corner, we have a couple of default monitors populated for you. So the defaults for fluid flow are pressure drop and max velocity. You can click here to reveal a chart. Okay, and this allows you to keep track of the different results you get for the different simulations that you do. Now you can look at our other tutorials to see how you can add additional monitors and so on, but these are the default monitors that are made available to you. Okay, so there you have it, your first simulation in Ansys Discovery for fluid flow in Explore mode. Like I said earlier, in part 2 of this tutorial, we're going to do the same thing, but we're going to use Refine mode, which is accessed right here down at the bottom. And in Refine mode, we're going to use our Ansys Fluent Solver, which runs on the CPU, to basically set up and solve the same problem with a couple of additional physics inputs. I hope you found that useful, and make sure to watch part 2. Thank you.